Okay, that was better. All right, guys, let's look at this. This is super cute. So pencils down. I'm going to talk for a little bit. Okay, absolute value won't put up with negativity. Okay, so put away values. Put any value but 0 behind bars, and the results will always be absolutely positive. Do you like it? So put any value but 0 behind bars, the absolute value bars, and the results will always be positive, absolutely positive. Okay, so let's talk about that for a second. Okay, so when we are talking about absolute value, and we isolate our absolute value, and we come up with a negative number, what do we say about that? Yes, Michael. What? No, you're right. No. Why is it no solution? Who knows why it's no solution? Okay, let's hear it. Sydney. If it's in the bars, it's positive, right? It's always got positive results, just like this. It's absolutely positive. So how can a positive number ever be equal to negative? It can't be, so it's no solution. Okay. Well, now when we're dealing with inequalities, it's a different story. Because it's not saying it's equal to 0. It's saying is this the greater gator or not? Yes, that's the greater gator. Okay, so if any number that I put in there, I put him away in bars, he's always going to be positive, right? So if he's always positive, could he be greater than a negative number? Yes. Everybody I put in there is going to be greater than a negative number. Isn't that true? Because it's positive. Even if I put negative a million in there, is it going to be greater than a negative number? So this is going to be every number from positive infinity to negative infinity could go in there for x. Every single number. Make sense? Any number could go in there. That's the same thing as saying all real numbers, or sometimes it's written like x is an element of the set of all real numbers. Actually, if you want to get really fancy, it would be x such that the set of all real numbers. Okay, so let's talk about a negative number. Sorry, let's talk about less than. So with less than, any number, any positive number, can any positive number be less than a negative number? Think about it. Can any positive number, can it be less than a negative number? If it's positive, can it be less than negative? No. Any positive number cannot be less than a negative number, so this one is. No solution. So we need to talk about that with your graph. Okay, really quick. Let me see which ones I went through in the last period. Okay. So I'm going to do this one. So this is what we did yesterday. So for what values of x is f of x greater than negative 2? So yesterday when you did your graphs on your homework and it didn't touch, what did you guys think? You thought no solution, right? But let's look at the absolute value, the v part of my graph right here. Let's look at the v part and figure out, and if this is my negative part, my negative 2, when is this graph greater than negative 2? It isn't? It is. It always is, right? Every part of that graph, no matter what part I'm looking at, is larger than or greater than negative 2. Correct? If this is the blue part right here, and I'm talking about it being greater than negative 2, it's always going to be greater. So we would say that this x is in between positive infinity and negative infinity. Or you could say x is an element of all real numbers. Wait, what? What? Are you sure? Okay. So I'm actually going to solve it really quick. So I would subtract 2 from both sides, and I would be left with the absolute value. Oh, I wanted to put that in blue, not black. The absolute value of x is greater than -4. So as soon as this is what we're doing today. We're solving algebraically. So as soon as I've isolated this and I have a negative, I say, wait, stop. We have absolute value can never be a negative number, right? Except when we have inequalities. So I say to myself, if this is a positive number, could it be bigger than a negative number? Yes, it could. So absolute, it's all real numbers. Thumbs up, thumbs down. How are we doing? Okay, I'm going to give you a chance to write this down, so just give me a second. Now let's look at the less than. So here's my absolute value graph, right here. Here's when it's equal to -2. Now let's talk about less than. Less than -2 is down here, whatever's shaded. Is my absolute graph anywhere in there? Never. It's never in there. Here's all the numbers that are less than -2, and my graph is way up here. It's nowhere near any of that. So this one happens to be no solution. And I'm going to do the math on it as well, so that we can see, because it doesn't make sense until it's isolated. You really can't consider it until it's completely isolated. So let's do it. So the absolute value of x is less than -5. If x is any positive number, can any positive number be less than a negative number? No. So this is no solution. Okay? All right. I think I'd like to do this one next. Let's look at this one. This was a homework problem, right? You're supposed to do this one on the back. You're supposed to graph it. What do you say about this? It's got to be either no solution or I only have 2 options. Or all real numbers. Okay? Let's graph it first. This is what you should have done yesterday for your homework. If I'm talking less than, then that would be everything below, right? Is that absolute value graph involved with everything below? Yes. So this one's going to be all real numbers. Okay? You know what? I am going to leave some room because I'm going to actually do this problem for you. So we'll put it down here. This one's going to be x is an element of all real numbers. And then let's look at this one. If we were talking greater than. Everything greater than that. Is that absolute value graph involved with anything that's greater than that? No. So what's this one going to be over here? Okay. So what I'm going to do right now, so on your homework problem, number 5 of your homework, look, just like this and just like this, the graph is gone. Okay? I'm going to leave the graph up here, but I'm going to do the homework problem. So right now in the presentation, I'm doing number 5 of your homework. Make sense? So when you want to go back and check your work, okay? And so this is also going to help you with, you can go and fix your homework from last night if you want to, and turn it in and get more credit, okay? Because you can, hopefully now that we've done the graphic and the algebraic, you can put the 2 together and and finish your homework. Okay, so everybody still pencils down, and then I'll give you a chance to put this on your homework a little bit later, okay? We're going to make sure that we get your homework to you before the bell rings. All right, so if I was going to solve this one algebraically, I would remember gamma, right? And we're going to work multiplication, division, addition, subtraction. We're going to work this way like that. So I need to, this is my absolute value. That's what I'm isolating. Isolating that guy right there. I can't consider any type of no solution. I wouldn't even guess it was no solution, right? Because that's not a negative number. But obviously it's going to end up being one, right? Okay, so if this, I'm trying to isolate this, it's being multiplied by negative 2/5 and added 7. 7 is added to it, so that's the first thing I'm going to get rid of is my addition subtraction. So I'm going to subtract 7 from both sides, and I'm left with negative 2/5. I'm going to need room on this side. Negative 2/5 is multiplied by the absolute value of x plus 4, and that's going to be less than 3. Okay? Now I'm left with multiplication. So we need to get rid of our multiplication or division. Since it's dividing, I'm going to multiply to get rid of it. So I'm going to multiply by negative 5 over 2. Multiply this side by negative 5 over 2. These are going to cancel. This one's over 1. So I'm left with the absolute value of x plus 4. I divided by a negative, so I better make sure I switch that sign. And I'm going to have negative 15 halves. Automatically, I can stop there. You can get fractions, that's okay, right? I'm going to stop there because I have that negative sign right there. That's caution right there. If this was an equal sign, I would already be writing what? No solution. I've now isolated. See how this is now isolated? I've isolated my absolute value. There's nothing on this side but absolute value, and I have a negative sign on this side. If this was an equal sign, a positive number can never equal a negative number, so we would write no solution. But it's not. It's an inequality, and it says a positive number must be bigger than a negative number. Is that true? A positive number is bigger than a negative number? It is, in fact, true. Therefore, we are talking about all the numbers on the number line, all real numbers. Okay, I'm going to go do this side. So same work, right? Same exact work, only the sign is going to switch. So I'm going to go a little bit faster on this one, okay? So subtract 7 from both sides. Then I have negative 2/5 x plus 4 is greater than 3. Then I'm going to multiply both sides. I should be changing, but I'm not because I'm trying to go fast. Negative 5 halves. Because I did that, I'm going to take the greater than, and it's now going to be less than. And then I have absolute value of x plus 4 is less than negative 15 halves. I now have an isolated absolute value, and I ask myself, can any positive number be less than a negative number? Any positive number. If I'm positive, can I be less than negative? No solution. Thumbs up, thumbs down. How are we doing? Okay, better than last period at this point. Erase that. Let's see. Do you guys think you can do one? This looks like a special case to me. It's a different special case, and this is number 6 on your homework. So let's do it algebraically and then look and make sense of the graph with it. I am recording. I better be recording. I am. Okay. So why don't you guys do number 6, this one on your whiteboards for me, please? I want you to do this one. Only I'm going to change that to this. Do this one for me, please. 1. Okay, there's another minute. Erase. Okay, guys. Check this out. Let's look at it graphically first. So if I were to shade, we're talking less than. So if I were to shade everything less than the graph, is it interacting with the graph at all? It is. It's interacting at one point right there at the origin. Not the origin, but the vertex. Right? So it's not, the graph is not less than 1 at any point except for right there at the vertex. That's the only place that is seen interacting with the graph. Okay? All right, so let's do it algebraically. So the first thing I would do is I would subtract 1 from both sides, and that would give me 2 times the absolute value of x is less than or equal to a 1 minus a 1 is a 0. Then I would divide both sides by 2, and I would get absolute value of x is less than or equal to 0. Can any positive number be less than 0? No. No positive number can be smaller than 0, except for 0. 0 can be less than or equal to 0 because it says equal to. So the only solution to this is x can only be 0. Okay, it only has one solution. All right, you guys try that one on that side, please. Okay, so actually, let me see your answers first before I record. Okay, so let's look at this one graphically this time. So if I'm talking about anything greater, well, if I'm talking anything greater than 1, right? Anything greater than or equal to, what would that include? Almost all real numbers. Check this out. I'm going to get 2 times the absolute value of x is greater than or equal to 0. Divide by 2. And I get, I get the absolute value of x is greater than or equal to 0. Is every positive number greater than 0? Yes. Is 0 greater than or equal to 0? Yes. I was thinking of the other case. No. It can be 0 because of this equal sign. What if it didn't have an equal sign? If it didn't have this, can 0 be bigger than 0? It would be x is larger than every 0, or x is smaller than 0. See the difference? Okay, I don't want you guys to get too hung up on this because we don't work with special cases very often. Okay? So, it's going to be, is 0 bigger than or equal to 0? Yes, so this is going to be all real numbers. And you kind of just have to look at the graph, right? So if it said, if this was not included, then we wouldn't be able, we would have to say every number but 0. Okay, because at 0 it's equal to. Okay, so it would be all real numbers. What? Yes, Kayla. This is all real numbers. I know, I was thinking, I forgot about the equal sign. Yes. Yes. Okay. All right, moving on. Let's see. Should we do number 7 too? You think you got it? Okay, let's go to your homework. We're going to do number 4 on your, actually, I'm going to have you guys do, write that down in your notes, and I'm going to pass out your homework, okay? So when I pass out your homework, go ahead and do number 4, and then I'm going to show you if you did it right or not, okay? I'm going to read this to you just in case, so that when you're writing it, if you want to write it a different way, you can. So what this says, solving absolute value inequalities algebraically. Here are your steps. Isolate absolute value, set up 2 problems, solve each, graph on a number line, okay? But what we've been working with right now is there's a star for that. If, once you isolate it, so once you have absolute value all by itself, and it's less than a negative number, that's what's important here. Less than a negative number, or if the absolute value is greater than a negative number, you need to ask yourself what makes sense. So can a positive number be greater than a negative number? Yes, always. Can a positive number be less than a negative number? Never. Okay? You can go ahead and get that in your notes, and then you've got your homework now, so do number 4, and then we'll do it together. All right. So let me do number 4 with you. 5, 4, 3, 2, 1. I need all pencils down. All pencils down, please. Okay, so my first step is to isolate the absolute value. I can't do anything with the absolute value. Hello? Hello? Yes, come here now. I'm teaching right now. You can't call me when when I'm teaching. Come in here. I already told you what to do. Okay, bye. She has her sister's phone, so she wanted to use it. And she knew that was the only way she'd be able to use it. Okay. And I'm recording. Perfect. Sorry about that, guys. Okay, so I want to isolate the absolute value of x plus 2. Okay? I have an emergency. My daughter is at camp, and my little 8-year-old that means she can't walk home alone. So she's got her sister's phone, and she's getting a ride here to the high school right now. I know. Okay, I'm trying to explain in the recording. Okay, so what I'm going to do is I'm going to add 4 to both sides first, so I can isolate x. Now I've got the absolute value of x plus 2 is less than or equal to positive 4 and negative 2 is positive 2. Are you kidding me? All right, sorry about that one more time, guys. I'm really, really sorry. Okay, so the absolute value of x plus 2 is less than or equal to 2. So now that it's isolated, I can go ahead and split it in half. That's the part we weren't doing earlier because we were getting negative numbers and we would stop, right? And think about it. So at this point, we're going to think about x plus 2 is less than or equal to 2. X plus 2 is greater than or equal to negative 2. Mallory, text Ryan and tell him that you're in my classroom. Thank you. Okay. Because we're talking about the other side of the number line, the negative numbers, So we had to switch the sign and make it a -2. You got it? Okay. So now to continue, all I have to do is subtract 2 from both sides, and I get x is less than or equal to 0. And on this side, I'm also going to subtract 2 from both sides, but this time I get x is greater than or equal to -4. Now I need to write that on number line. So when I write that on number line, I'm talking about a -4, so I might as well write -4. I'm also talking about a 0. 0 is bigger than -4. X is greater than, okay, let's look at this problem again. Less than. Is less than going to be like this, or is less than going to be like this? It's going to be like, good job, guys. You guys are awesome. So I already know, without even doing the problem, I already know that it's going to be x is in between 0 and -4, right? Just because I know my signs. But if I wasn't sure, I could look at this. X is greater than -4. So greater than, and then it says equal to. So we're going to fill that in. Greater than goes this way. And x is less than or equal to 0. So I'm going to fill it in because it said equal to. And it's less. So does this match this? Thank you. It should have the equal. Okay. Thumbs up, thumbs down. How are you guys doing? Can we do our homework? Oh, I've got all thumbs up. Fantastic. Good job, guys. I'm going to go ahead and